Hello and welcome to the channel. Today we're going to take a deep dive into regions and locations. Now regions is something we've touched on very briefly before in the video that I did on device pools, but we didn't really go very far at all with that video, so we're going to do that here today. We're also going to talk about locations, which has to do with call admission control, or CAC. Now there are multiple ways that you can administer CAC, but we're just going to focus on locations-based CAC for today. So before we get into the configuration side of things, we need to talk a little bit about bandwidth and the issues that a typical enterprise network encounters. So an enterprise network uses bandwidth for a wide range of purposes, and IP-based communications usually crosses the same network edge, meaning that edge router. So for example, you could have voice and video traffic crossing the WAN while large files are being transferred over FTP to a remote location. And at the same time, devices are accessing email and other services in the cloud like Office 365 or something like that. So the result of these devices competing for bandwidth across the company's network causes congestion on the network edge and uses up all of that extra bandwidth. So individual sites of multi-site deployment usually interconnect by an IP WAN, and bandwidth on WAN links is limited and relatively expensive as well. Therefore, the goal is to use the available bandwidth as efficiently as possible and discourage unnecessary traffic such as social media sites of personal use. And of course, you should also consider implementing other additional methods of optimizing bandwidth, most of which we're not really going to get into today, but we're going to talk about a few. So you might be thinking, well, what about QoS? Now, implementing QoS policies will certainly help during high congestion times, but QoS doesn't prevent overutilization of bandwidth. Instead, what it does is it prioritizes which packets get across the network during these high congestion times. But you can still have issues with overutilization. So Cisco has several call admission control mechanisms that can be implemented, which will control how bandwidth is used across your network. So let's take a look at what happens on the network when bandwidth is overutilized. So assume in this scenario that the WAN can handle up to 1 megabyte of bandwidth total. Obviously a WAN link can have a lot more than that, but 1 megabyte is easy for me to do the math on. So if the two endpoints shown in this slide place a call using the G.711 codec for audio, then they'll actually consume 87.2 kilobits per second for that call, because 64 kilobits is the payload, but you have to calculate an extra 23.2 kilobits for the headers that are included here. That means this WAN link can support roughly up to 11 calls, assuming that there's no other network traffic consuming bandwidth at the time that these calls are placed. So that sort of prompts the question then, what happens when the 12th call is placed? Well, in this case, the call isn't dropped. Instead, the call leg will begin to borrow bandwidth from the other existing calls, and every call that's taking place will suffer a loss in quality, like choppy audio, for example. And so this is certainly something we want to avoid, so this is where call admission control comes into the picture. Using CAC on the CUCM allows administrators to control the codec used on both a per call basis, depending on the site that calls are placed, as well as the total bandwidth or overall bandwidth that all simultaneous calls are going across the WAN. And by the way, just a quick side note, another way to deal with this scenario is with AAR, which is actually another layer of locations-based CAC, but that's a whole separate can of worms that will need a separate video. But I'm mentioning it now because I will be doing that video soon, so check in the upper right-hand corner for a link or look down in the description. If you don't see it now, you'll see it soon. Okay, so call admission control. We're dealing with regions and locations, and regions is the first thing that we want to look at. Regions controls which codecs you use between endpoints when calls are set up. This is a specific bandwidth allocation associated with each audio codec, and it allows you to easily plan and sort of predict how much bandwidth is going to be consumed. Okay, so for example, G.711 is an uncompressed codec and it consumes 87.2 kilobits per call on average for audio quality. And that's consistent with every call that uses G.711 codec. On the other hand, G.729 is a compressed audio codec, and although it consumes only 31.2 kilobits per second, it suffers from poor quality during the call. It's not as clear as G.711. And then you have this range of other codecs that could be compressed or uncompressed, and they're going to have varying levels of quality accordingly. So this is where codecs come into play. So now let's talk about data compression. So compression involves utilizing encoding algorithms to reduce the size of the digital data. Compressed data must also be decompressed before it can be used. This extra processing imposes computational and other costs during transmission. Now, two different compression techniques you'll hear about a lot are lossless and lossy. Now, these terms describe whether the data in question is recovered exactly bit for bit when the file is decompressed, or whether the data is reduced by permanently altering or even eliminating certain bits of data, especially redundant bits. Now, lossless compression analyzes data for statistically redundant information that can be represented in a compressed state without losing any of its original information. For example, in places where there is repeated information, for example, it can just look at the first instance of that information, create a shortened representation of that data, and then insert that representation at the appropriate places throughout the data stream. So the main point to remember here is that all of the original information is maintained so that when it's decompressed on the other end, it's basically unchanged. Now, lossy, on the other hand, this searches for the non-essential content that can be completely deleted in an effort to conserve the amount of data that's being sent over the network. So basically, in a voice call, it's looking for the non-audible components of a conversation. That could be perhaps moments of silence or pauses between sentences, for example, and then it just eliminates the information altogether. Now, audio is consistent, and you tend to know what to expect, very steady. Video, on the other hand, it's different. Video can be very bursty and greedy when it comes to bandwidth consumption. So to illustrate what I mean, let's say that I have a 384 call. I mean a video call, right? So 64K might be allocated to audio, and that means I have 320K allocated to video. Now, video might not use the full 320K. It might only be using, say, 128K or 256K, because maybe the video doesn't have a lot of motion in it. Let's say, for example, you have just a talking head, which means that it doesn't need to refresh a lot of the screen. But then say all of a sudden the person starts moving around, maybe they get up or whatever, and so it will need to refresh more of the frame. And so the bandwidth requirement suddenly increases or it bursts in order to keep up with the amount of data that it needs to transmit. So this is what bursty and greedy refer to when we're talking about video. So again, with audio, I can specify a particular codec I want to use, say G.711 or G.729, and I know exactly how much bandwidth I'm going to consume with it. Very predictable, very stable. But with video, we're only going to be setting the maximum bandwidth that's allowed on a per call basis. So we're not going to set a specific codec with the video call. We're only saying that this is the maximum bandwidth per call an endpoint will be allowed to use. The actual codec that's used is determined by the endpoint at the time of the call. Okay, so hopefully that makes sense. So let's take a look at some examples of video. This table shows the codec, the highest quality that can be achieved with that codec, and actually lower qualities are possible, of course. But here I'm just focusing on the highest. And then the minimum bandwidth that's recommended to achieve that quality. So if I want to do a 480p 30 call, it's recommended that I use a minimum of 384 kilobits per second. But again, that's just the minimum. There's no reason why I couldn't do a 480p call at, say, 2 meg. Okay? And like I said, these codecs, they can be used at a lower quality. So for example, if we specify 384 kilobits per second in our region settings, it doesn't mean that we're forcing the endpoint to use H.261. It could still use, for example, H.264, but of course, in that case, it would have to be at a lower resolution, okay? But one of the reasons I'm focusing on the maximum quality for these codecs is because it illustrates one really important point, and that's efficiency. So let's look at this. If I did a 1080p 30 frames per second call using H.263, I have to consume a minimum of 1536 kilobits per second in order to maintain that call. But I can do a 1080p call at 60 frames per second using H.264, and I'm only using 2 meg. So in other words, I'm doubling the frame rate of H.263, but I'm using only a little bit more bandwidth. And it gets even better with H.265. I could do 1080p 60 at only 1 meg. So there's certainly an increase in efficiency as you move up. But again, you're not going to have any control over what codec your endpoints use for video. You can only set the maximum bit rate that they're allowed to use, and the endpoint will decide which codec is best based on the limitations that are placed on it. Okay, so you can see this by looking at the screen capture from the region settings in the CUCM, and I'm going to go into a live session here in a few minutes. But for now, notice that with audio, we're specifying the codec, but with video, we're just setting the maximum bit rate for our UC video or telepresence endpoints. And remember, it's important to keep in mind that region settings are on a per call basis. Okay, so hopefully that makes sense. Okay, so these UC video endpoints, this would include like the 8900 and 9900 series IP video phones, 8845 and 8865 IP video phones as well, and the Jabber client. So Jabber is UC. The immersive video calls column, now this has to do with any Cisco telepresence video endpoints. So we're talking about DX80, MX700, SX80, or any of the WebEx endpoints. Okay, so let's now take a look at locations. So where regions deals more with a per call bandwidth, locations controls total bandwidth consumption for all calls at any given point. So to start off with, there are 3 locations that are defined on a CUCM. There's Hub None, Phantom, and Shadow. Briefly, Hub None is configured by default with the unlimited intra-location bandwidth allocations for audio, video, and immersive bandwidth. So everything is unlimited by default. Phantom is unlimited bandwidth for audio, video, and immersive calls and is used across SIP or H.23 trunks, either one. And then Shadow, now this is a system location created for intercluster enhanced location CAC. In order to pass locations across clusters, the SIP intercluster trunk can be assigned to the system shadow location. Now, these are just default locations that come pre-configured, so if you wanted to create your own locations, certainly you could use those instead. And in fact, I would suggest that you do just that. I wouldn't recommend using any of these default locations. Okay, so let's talk about that. Let's talk about how you configure your own location settings. So remember, when setting up locations, the bandwidth rate is the total bandwidth. It's not a per call bandwidth as it is with regions. Also, very important here, overhead is not calculated automatically. So when you're calculating your bandwidth allocations, you have to include the overhead as well. Now, audio is pretty easy to calculate. And in fact, you could just look at that table that I showed you earlier, the one showing audio codecs for regions. You could even use these totals to figure your audio. But video is a bit trickier. For video calls, the best rule of thumb is to add 20% to each call rate, then multiply by the number of calls allowed. So for example, if the call rate is 384 kilobits per second, I'd want to multiply it by 1.2 because we're adding 20% to give it a total of 460 kilobits per second. So if you wanted to support 10 calls, then it would be 460 times 10, and that equals 4,600 kilobits per second. And that's how much total bandwidth that you have to allocate. So a few things to consider about that. For example, just for the sake of argument, what if your WAN link was only 2 meg? Obviously, you couldn't support 10 calls at 460. You'd have to reduce the number of simultaneous calls because 384 is the absolute lowest that you'd want to go for video. Okay? Also, in a real scenario, you don't want to try to calculate the maximum number of calls that you could support based on your WAN link because there's obviously there's going to be other traffic like emails, file shares, and other important traffic. So you have to leave bandwidth for those other services as well. So it takes some time to do some careful network diagnostics to see how bandwidth is being used in order to calculate how much you can allocate for your audio and video services. So we're going to go into the CUCM now, and I want to show you how to configure all of this. So let's first configure our regions. Now, we've done regions at least in another video before, but hopefully it'll make more sense now. So let's go to System, Region Information, and then Region, and then we're going to click Add New to create a new region. And we'll call this one Kobe_RGN, and then click Save. So this is my Kobe region, and we know that I'm in my Kobe region because it says so up here under the region information. So the way you need to think about it is that you're creating a setting that your endpoints are going to use if you're calling from this region, Kobe_ region, to whichever region you select down here in this window. Now, right now, I only have the default region and the Kobe region. So by selecting Kobe_ region here, I'm saying that I'm configuring the settings for when I'm calling from Kobe to Kobe. In other words, when I'm calling within my own region. So I've got it selected here. Now, what preferences do I want? Well, here under the audio codec preference list, remember we can set lossy or low loss, or we can keep the system default, which I think will work for our purposes here. Now for audio, because I'm calling within the same region, I'm just calling on the same LAN, so I've got bandwidth to spare. So let's give it a higher codec preference here. Let's say 64 kilobits per second, G.722, G.711, uncompressed audio. Now for video bitrate, again, we're not selecting any codecs here. We're just setting the max bitrate. So for this, we're going to put in 768. Now 768K is typically what you need for a 720p 30 HD video call. So that should work. And then telepresence, I'm going to say 2048. And again, all of these settings are going to be applied per call. So let's go ahead and save this. Now, as you can see under region relationships, when I call Kobe to Kobe, I'm going to use a system default, which is low loss, 64K for audio, 768 for UC video, and 2048 for telepresence video. And that may seem a little high, but remember here we're just calling over the LAN because it's within the same region, so really it's fine. So let's create a new region. So we'll come up here and click Add New, and we'll call this one Dallas_RGN, and then click Save. And now we're in the Dallas region, and we can see that because it says Dallas here. So I need to think about how I want my settings configured if I'm calling from Dallas up here. Well, let's go ahead and select Dallas again down here. So again, we're configuring settings for an intra-region call, a call within the same region. So this means we're on the same LAN. So once again, we're going to have bandwidth to spare, and we can configure Dallas to Dallas calls with the exact same settings that we did for Kobe to Kobe. So for audio codec preference list, we're going to use the system default. For audio codec, we'll select 64 G.711, 722. And for UC video, we'll select 768, and for telepresence, 2048, and then click Save. And then, of course, we can see these settings under the region relationship here. Now we need to configure for when we're calling across the WAN, either from Kobe to Dallas or Dallas to Kobe. Now, what's really nice about this is that we can configure it one way, and then the CUCM will configure it for us in the reverse direction automatically. So all we really need to do is configure it for Dallas to Kobe, and then it will automatically be configured for Kobe to Dallas. So we're already in the Dallas region here. So we can just come down here and select Kobe_RGN. And in this case, for calls going across the WAN, we need to think about conserving our bandwidth. So what I'm going to do instead of low loss is I'm going to go ahead and put in factory default lossy. It's a higher compression, so it's less data that I have to send. And then for my audio bitrate, I'm going to use G.729. For video, I'm only going to do 384, and then for telepresence, I'm also going to do 384. It's SD quality, but that way I can conserve bandwidth. And then we'll click Save. So you can see that when I'm calling from Dallas to Dallas, I have a higher bandwidth allocation than when I'm calling from Dallas to Kobe, which uses G.729 for audio and 384 for video. Okay, so that's it for regions. Now let's configure locations. So I'm going to go to System, Location Info, Location, and when I click Find, you'll see the 3 default locations we talked about earlier. But we're going to create our own, of course, so we're going to click Add New, and we'll call this one Kobe_lock. Now, if you look down here, this is going to be for when we're calling from Kobe to hub none, which is actually never going to happen. And if we want to, we can just delete this later. So it doesn't really matter really what settings we give it here. And I know that sounds weird. You're probably wondering, well, if we're never going to use this, why are we configuring it? The reason is because we need a baseline. And remember, the only locations that exist so far are those defaults, the hub none, phantom, and shadow. So I'm creating this one so that we at least have a Kobe location that we can work with. So let's go ahead and click Save. You'll see what I mean. Now I'm going to click Add New to add a new location, and we're going to call this one Dallas_lock. So now I can configure the Dallas location to the Kobe location. So I'll select Kobe here. And this is why I created the first Kobe location in the first place, so that I'd be able to create this relationship between Dallas and Kobe. If I hadn't done that, then Kobe wouldn't even be available for me here to select. So hopefully that makes sense. Okay, so now I want to limit my audio bandwidth. Now, when I say audio here, this is only going to be implemented with audio-only calls, no video. If I say video, that's including video with audio together. So for audio-only calls, I'm going to say 1024K bandwidth. Now, that may seem a little high, but it's actually kind of low because remember, we're no longer talking about a per call bandwidth. We're talking about bandwidth of all of our calls together. So this could support about, what is that, 5 audio calls on 1024 bandwidth. And then for video bandwidth, we're going to say 2048. And for telepresence, we'll say the same thing. Now, in a normal production environment, these totals could be much more, of course. But really, it all depends on 2 things. A, what are your WAN capabilities? And B, how many calls do you want to be able to support across the WAN link at the same time? Okay, so we're going to save those settings. And notice now, if I'm calling from Dallas to Kobe, these are the bandwidth limitations. Again, for simultaneous calls going across the WAN. And just like with regions, when we configure from Kobe to Dallas, for example, it will automatically configure the settings in reverse from Dallas to Kobe. So we're pretty much set here. Now remember, with regions, we had to configure our settings not just across the WAN from Kobe to Dallas, but also within the same region. Well, with locations, we don't have to do this because location bandwidth restrictions are not applied if you're in the same location. So if someone in Kobe is calling someone else in Kobe, you'll have a per call maximum bit rate applied through the region settings, but there are no total bandwidth restrictions applied through locations. So we really don't need to worry about this. Okay, so I've created my regions and my locations. Now what I need to do is apply them to a device pool. So let's go to System, Device Pool, and then click Add New. And we'll call this one Kobe_DP, and we'll choose our default CUCM group. For this, any date-time group is fine. And then for region, of course, I'll select Kobe_region. And just a couple below that, under location, I can choose Kobe_lock. And I'll click Save. Now, I know this is a really long video, but there's one more really important thing that I want to show you before we bring this to a close. So let's go up like we're going to add a phone. Let's go to Device, Phone, and then Add New. And it doesn't really matter. Let's just choose 9971. Click Next. Now here we put in the MAC address. I'll just put in whatever. It doesn't matter. And the description, that doesn't matter either. Okay, here we're going to choose our Kobe device pool, which has all of our region and location settings that we just configured included in it. Okay, so what I want to show you is this. Look down here where it has the field for location and notice that it says Hub None. So remember this. This is really important. The location setting in the device pool takes precedence over what's listed in this field here. If a location configuration isn't added to the device pool, of course, it's going to use a location setting here, but otherwise, the location that's been added in the device pool is the location that's going to be applied to the phone. Okay, very important there. Okay, that should just about do it for this one. If you like this video, give it a thumbs up and subscribe if you haven't already. Otherwise, that's it for now. Thanks for watching.